So, I'm Sasha Hart, and my talk is about getting along with Python. The basic theme here is that there are things you can do which are going to make your life significantly better with Python that you might not know about. This talk is a little bit oriented towards people who are not like super advanced in Python already, but at the same time, I sort of assume that you already have done like an introductory course or tutorial and maybe like a project or two. So if at any time you decide that this is boring, like I'm not gonna be offended if you walk out and go look at something else, that's cool. Am I moving the slides around? No, okay. All right, so, verify this. Basic setup, I really enjoy using Python. I've been using Python for way too many years. But I've noticed that a whole lot of people are out there suffering with one or another problem that is like completely gratuitous and unnecessary, okay? And they don't know it. And by the way, that was also me with many problems for many years. Of course, there's still probably other things that are like that for me, but some of the things I'm gonna talk about today are things that I learned only last like 5 years or whatever. Oh, I'm sorry. So, essentially, the problem I'm identifying is that a lot of these problems are like truly gratuitous. They're not things that we all have to deal with, but they're things that like nobody just tells you what's going on. And the kind of stuff that I'm talking about is the stuff that's around the programming. I mean, like tools that can make life a little easier to access, help you out of trouble, and idioms that help you go with the flow of Python. I mean, even everyone has their own ideas or ways of doing things, but sometimes it's just gonna make your life a lot easier to like do other people around you or work with the design tool you're using. Am I audible? Okay. All right. So essentially, Python courses before it's all about the coding, and you can come to conferences and you can hear like stories about what people are doing in the industry and whatever, and that's actually really useful. But there's sort of a gap in between, right? Where you've heard about the coding and you've heard about like what people are actually doing in industry, but there's a whole lot of like nitty-gritty practice stuff that you haven't heard about. One of the major things that we're missing a lot of the time with respect to practices like, I don't know, version control, is we don't really explain to beginners or people like me some years ago why we do these things, right? People are just like, use version control, and you know it helps like if you just follow that kind of instruction, but at the same time people might look at it and say, well, this is a big pain in the butt, what's in it for me? And I think we really should do a better job of explaining that, and part of the reason is, you know, some of these pain points with Python like have been solved years ago, but people don't know about them, and so it goes on and on as this thing which is supposedly like a terrible thing about Python. If you just know like one or two things, it's not so bad, but if you don't know, then you end up like swimming through the sea of like completely random weird links and like stupid stuff people are saying on Stack Overflow or whatever, and you have no idea which end is up. And this is applied to me too. Like it doesn't necessarily have to be a problem for beginners only. Often there's a way that things are done, but it's not like communicated very broadly. So when I've been working with people or working with Python learning groups or whatever, I found that I kept explaining the same things over and over to people. Like they're like, well, how do I install a package? I have no idea what I'm doing. And I'll be like, oh, that's actually pretty easy. I'll explain this and that. And they're like, oh my God, thank you. That was so simple. But if I keep saying the same thing over and over, it gets a little bit repetitive. So I wrote sort of a book. Actually, it's more site, so I'm not sure. But anyway, and the book's about looking at practices in Python, like having harmonious Python by using these practices. And there's actually there's a whole lot of material. There's way too much to go through here. But basically, it's a pretty broad survey. So all I'm going to do in this presentation is sort of like hit the high points of what I discuss in the book and tell you sort of a basic idea of what each practice I'm recommending is and basically why. Okay, and there's a lot more argument and detail and examples and stuff on the actual site. And this is all kind of beta. I haven't got a whole lot of feedback on it yet, so by all means, if you get use out of it, let me know. Okay, and before I get into the meat of it, I want to make some upfront disclaimers. The first thing is, if you're looking for help with Python problems or you want to have a better life with Python, I'm going to strongly recommend that you hear one of these practices, you don't immediately discard it out of hand. And if you try it, right, like really try it, like stick to it for a little while so that you like have personal experience. And if you decide this practice sucks and is pointless, I want that to be on the basis of real information, because what I'm doing here is like I'm not so much offering my personal opinions as I'm trying to distill the things that I've heard and the things that I've seen other people doing. And so I'm going to ask, if you follow this at all, try to really like give it a good shot so you have some understanding of what it is first.
Okay, another disclaimer that's kind of important is I do express some opinions,
And the reason is I want to encourage people to take advantage of what's out there and have a better life with Python. But in order to do that, I can't avoid like having some opinions and saying some things. And I try to be ecumenical with it, but I'm not always going to succeed perfectly with that. But the reason is if I try to avoid all controversy, we're right back to the old situation where people who are coming out of intro courses are really not getting hardly any of this information on like basic practical details. And I want to reassure people there are going to be a number of people in here who are actually relatively experienced with Python and will find something to disagree with. I want to reassure you, my point here really is I'm trying to help. There are considerations around my recommendations like that they apply to more than a small minority of users. There are specialized tools or practices that you might be using in a specific part of the industry that are important, and I'm not denying those, but I'm saying here are some good defaults to start with. So if you're really experienced, I'm going to just ask you, please, I don't want to have an argument about tabs versus spaces, okay? All right, so there's a whole lot here, and what I'm actually going to do is it's not going to take all that long, but I'm going to walk through some of the basic topics, like basically what's painful when you're not doing this thing, and essentially what the nature of the solution is. And, but I'm going to leave plenty of time afterwards so we can have discussion or questions or whatever. So essentially, you can see here I'm covering a number of different topics, talking about installing packages, managing dependencies, using version control, using style, running checkers, testing, logging, using a debugger, building documentation, and making your own packages. And I'm not going to cover any of these in deep detail, so if you need more detail, the site is there. It's an introduction, and you can go and find your other sources as you need to, just for your convenience. So my first big recommendation is please just use pip as your default package installer. I know there's other things out there, but I see so many people suffering in so many ways around package installation. And here are the main alternatives that I see out there. One is that there are people who are afraid of installing Python packages because they've had problems where they don't know how to do it. And so then when they're writing code, they're like, I don't want any dependencies. You have no idea how common this is. Like everyone is doing this. I don't want any dependencies. The reason for this is that they're afraid of dealing with packages. Once you have a way of dealing with packages, 95% of the time, you just install what you need. But it's very easy to get all sort of screwed up inside and be like, I can't deal with this. I'm just going to rewrite everything myself in raw Python against the standard library. It's hell. It's terrible. Another thing that I've seen people doing is, yeah, they'll use Python dependencies, but only stuff that their distro gives them. So I use Ubuntu a lot. There are a lot of people out there who have the idea that they only want to develop against packages that are available on their distro. It really limits your options. Not everything is packaged. The versions are often lagging. I'm not saying that in production, if you think that, if it's your judgment that you need to use the distro's version of a package, that's fine, it's a different issue. But for development, you should really know how to use pip. And there's some older things that people used to do. I remember back in the early 2000s, we're doing a lot of Python setup.py. You download the tarball, and you'd uncompress the tarball, and you'd Python setup.py, okay? Or even, I'm sorry, sudo setup, Python setup.py, okay? And, or later on, we got easy install. It's better, but easy install is you can't uninstall, so it's sort of Hotel California. So anyway, okay. And so there's new things that are out. There's new things that are out now, like Conda, but often other things that aren't what they're designed for kind of just subtly break. And so there's a de facto community standard here in pip. Pip is even available by default with Python 3.4. And so by now, if you don't know pip, you can use those stuff if you want, but if you don't know pip, you're in trouble. Okay, so when you're using pip, it's actually, most of the time, it's really not hard to install any version of essentially anything on PyPI. And when you deal with things like virtualenv or wheel, just works, no problem. And if this is a really key detail. If you are having problems where you find that you are modifying the environment variable Python path, or you are inserting things into sys.path, or you are manually CDing into site packages and adding or removing files, okay, these are a sure sign that most of the time you should probably just be using pip, okay? Because I did that stuff back in the early 2000s, and I hated it, and it made my life worse, and it's so much better now that we have a better thing for several years now. So I'm recommending Bit. And the initial downside of it is, installing it the first time, because you don't have an installer already installed on most versions of Python, is sort of slightly irritating. So it can take you a few minutes. I'm so sorry. Just give it a try, okay? I have a link to some documentation there. I'll post the slides afterward. All right, next thing. You might have heard about this thing, virtualenv. It's rarely explained what it does. People just like use it, and that's a pretty good idea, but I'll explain it. Essentially, a virtualenv is nothing but a directory with some files in it, and those files are a mini installation of Python, okay? And what you can do with that mini installation of Python is you can run your programs in that, and they're isolated from other installations of Python, including the system Python. Okay, so essentially, if you need two different versions of a single library for two different projects, no problem, they can live together, but they're each living in their own virtualenv. It's very, very common and normal to deploy in virtualenvs. There are alternatives you can use, but it's a good thing to start with if you are not super old in Python. So I've given a few examples of the kind of things that happen. You can really only use one Python. For example, your system has Python 2.7, you want to try out 3.4. Oops, sorry, it's a difficulty. You're always typing out Python 3 or you're writing Python 3 in your hash banks. You don't necessarily have to do that. You can use virtualenv to manage which version is being run. If you are dealing with issues where like your package is tied to the system's version of a library, now the system upgrades the library, now your package is broken, you have to scramble for it. Okay, again, that sucks. It would be nicer if you had, let's say, a virtualenv, and it has the versions that you need in there, and then when you want to make an upgrade, you can look before you leave. You get the basic idea. I'm not going to go way too much into it, but another key advantage is when you install things in a virtualenv, the virtualenv is just a directory that belongs to you like normal, and you don't have to use sudo, and you're not messing with stuff in the system. If you screw everything up inside a virtualenv, no problem, just destroy the virtualenv. It's all undone, okay? So you can experiment very freely, and it's very, very useful. And another thing which is really for other people more than it is for you is if you develop without using something like virtualenv, then it's very common for you to develop dependencies to things that you haven't documented. You're making a lot of assumptions about your environment with regard to Python or its dependencies that are fragile assumptions. And so then when you try to deploy on a slightly different machine, you find out it doesn't work there, and you're forced to contend to the person who's seeing it broken. Oh, well, it works on my machine. Well, that sucks. So by all means, I recommend virtualenv. Here's an example. Simple example of usage. You see at the beginning I'm showing my system Python is 2.7. Then I'm actually running the program virtualenv, and I'm telling it that I want Python 3.4, and I want to make a virtualenv in a directory called env. And then you see a few lines, virtualenv is running and making the thing, it gets finished. And then I'm sourcing a little bit of shell script. This works when you're using shell. And essentially, after that activation, when you type Python, it means the Python that's in your mini installation in the virtualenv. And that Python is using the libraries that are installed in that virtualenv. So just in the example, I'm just for no reason installing Django, and then I'm running a Django command that only exists inside this virtualenv while it's activated. And I'm documenting essentially what I have installed. And then when I type deactivate, it pops me right back out of that environment. I'm back in the system environment, okay? So it's kind of a sandbox. And this might be a little bit overwhelming at first. There's a bunch of explanations how to do it. I recommend use any of them. I provide one. In GOP, it doesn't matter. This one is kind of long on preaching, and it's kind of hard to avoid that. Okay, one thing that really makes life with Python easier, even though it's not Python specific, is to use version control religiously. I don't really care what you use, if it's Git or Mercurial or whatever. There's all kinds of like flame wars about it. I like Git, but it doesn't matter. But it's really, really crucial because, before I was like, I don't know, 10, 15 years ago, before I was using version control at all, I was like copying my directories. I'm about to do something dangerous. I like copy the entire directory of my project over and over and over. And I have like 200 of them, and like then I'm like, okay, well at least I kept the date on each one, but like sometimes I didn't. and it's very bad. So there's several possible pitfalls. Like you often will destroy work. You don't have any enduring records. So you say, shit, I just deleted my work. Shit, which directory is the newest version out of all these hundreds? And this is one of the biggest ones. Is you have all these different versions of your code, and this is one of the most common problems without version control. Shit, merging these directories is completely insane. And if you're saying this kind of stuff to yourself, it's really time to look into version control. So I really want to emphasize this. Please use version control. And a lot of the reason why people don't is because it's intimidating to learn one of these tools, right? There are these command line tools, and that's a barrier to some people, and they often have a lot of options. But I want to emphasize to you, listen, even that little bit of investment is still going to be way, way, way nicer in the long run. And actually, you don't have to learn everything often to use something like get or a subversion. You really only need like a couple commands to start recording your changes, and you can worry later about how you're actually going to like consume that and rewind and stuff like that. And I just want to emphasize, like, everyone expects you to do this. Like I don't like to be too preachy, but seriously, you really have to do it. And so I have a brief guide on it in GOT, but there's a bunch of tutorials which go into a great deal of depth. Well, I'm racing. Okay, so this is a contentious one that people fight about a lot, but I find that it makes dealing with Python a lot easier. Python has some standards for how you format your code, okay? And it's really helpful if you can follow them to you, because otherwise you have several symptoms of no Pepe. One is, okay, inside your team of people that you're working with, there's constant argument about things like tabs versus spaces. Okay, and these are usually almost entirely inconsequential, but even if they are consequential, it's not enough that it's really worth the heat and time taken. But I think another big benefit to you of getting at least used to it is, you know, you're going to be reading a lot of other people's Python code, and like it or not, a lot of other people have adopted this convention, and so you're going to constantly be crazy if you really care about this in Python, and you can't just sort of suck it up a little bit. And then, of course, there are people like me who will be very irritated if you're working on the team and you're doing a completely different style, and we have to deal with this on every commit. But that said, there are sub-communities and there are shops which have completely different styles. Google defines its own style. There's a different community style for Twisted. There's somewhat different style in SciPy and NumPy communities in some places. So it's important to like pay attention to where you are and what you're doing. But I think as a good default, if you just want to be a general Python person and you're not specifically embedded in one community, it's good to at least be conversant with Pepe and have an idea of how to deal with it. Yeah. I have an entire lightning talk about editors at the end of the day if you want to see that, yes. Okay, another recommendation. Okay, Python is a dynamically typed language, and it's very hard, never mind what that means, it's very hard to write programs which can verify everything that you believe to be true about your programs, but we do have a couple really good tools that I recommend using on a regular basis. One is Pylint, and Pylint is sort of the code Nazi, because it will find anything that anyone might complain about your code and then some more things. And so there are a lot of people who are like, well, I hate Pylint. Well, one thing is you can turn off classes of error messages you don't like from Pylint, but the other thing is the basic use of Pylint is to be hard on you. And so I find that if I periodically run Pylint, it actually helps me identify places in my code where I was like falling asleep or I was drunk. So another tool that's really useful for pretty much everybody is Flake8, and it's actually very quick. So but it doesn't complain very much, and so it's really nice to run over and over again, and it will detect things like you're using the name of a variable that doesn't exist, so you don't have to actually run all of your code and get to the stage of getting it caught by a unit tester or debugger before you realize the problem. And of course, these static checkers are super useful, and they do make life better in the long run, but there's not really any substitute for you or someone else like carefully sitting down and reviewing your code. This is a big thing that that I think often doesn't get explained very well to people who are beginners or who are just sort of cowboy hacking is automated testing. We talk a lot about unit testing and other categories of testing, but it's rarely really spelled out very much to people why they would want to do it. And I think once you've done it and you understand it, that I think it's kind of self-evident that it is really helpful to you, not just to other people. Because if you're writing a program and you want it to work at all, you end up testing it somehow. If not necessarily in an automated way, then you keep running it and feeding input into it to see if it's working now or if you just broke it. And that effort, magnified over many thousands of changes, is a huge amount of time and a huge amount of repetition. If you can write a simple script that will run your other code and tell you when that other code failed, that's testing. That's enough to get started with, and it's very, very useful. So there are multiple tools in the Python world for doing this. Standard that's in the standard library is unit test. However, there's a diversity of things that people use and that are okay to use. I personally like PyTest very much. It offers both a test framework and a test runner, but unit test also offers those things, and I get a great deal of use out of talks for verifying that my code works across multiple versions of Python. So I don't want to misrepresent to you that like testing is necessarily easy or a shallow subject. It's a really deep discipline, and there's a whole lot of people who are specialists in it. And there's a lot of internal flame wars and stuff. There's a lot to learn, but just basically writing tests at all is probably a lot easier than you'd think if you're not doing it already, and has a great return on investment. So I really highly recommend that if you're writing Python, even at a pretty simple level, I really recommend that you get a little bit into testing. So I have a guide on that, but of course, there's many good guides out there if you don't like mine. This is something that almost treads into the category of stuff of actual coding, but I don't go all the way into it. Essentially, I'm recommending that people use the logging module, and the logging module it essentially is going to help you stop doing things like putting print statements into your code. And a lot of people, like I could ask people like how many people put print statements into their code, and like no one's going to raise their hand. But I know a lot of people do it, and like I still do it occasionally. And whenever I do it, I now know that means I should be import logging and starting to use logging in that program, because it's a huge advantage. You know, if you put a print statement into your code, no one can control that output. So they like import your code and run your little library function, and it prints all this garbage, which they didn't necessarily need to see. And furthermore, if you have a whole lot of print debugging, then you have a massive torrent of spam that can't be suppressed or redirected. And what logging does is it allows you to break up your messages into different streams and then independently control the level at which those streams are spammed to the log. And it also allows you to direct your log output to different places. And it's all done in a way that's standard in Python. So if you write a library, you can actually log messages, but as long as you are not being too intrusive to set up the logging system for other people, you can allow the users of your library to determine where that logging output goes and whether it's silenced or whatever. It's up to them, where it wasn't the case with print. So there's actually a lot of peculiarities and nuances with the logging module, because it's kind of an old module. And so I recommend that you read some documentation on it. I have a pretty simple guide to it. There is some old stuff in the Python reference material, and that works fine. It's just a little bit difficult to wade through. Another thing I recommend is to learn a debugger. I mean, I know that not everyone agrees on how to do debugging, and it can be pretty compelling to use print or, let's say, logging. But the time when you need a debugger, you won't really want to be fighting the debugger at the same time. The likelihood is that when you get into a really hairy problem where it will be extremely efficient to use a debugger instead of trying to track it down with printing, you really won't want to deal with the debugger at all, and you might just bypass it and flail for another 12 hours. So I recommend not doing that. I recommend getting a basic familiarity with some sort of debugger. PDB is the one that comes by default with Python. There's also third-party alternatives, which are nice in various ways. Like PODB is another console-based one, and WinPDB is a graphical one, which is not, it's not OS specific despite the name WinPDB. So whatever you learn, I think it's really good to get a basic familiarity with those so you can step through your code and check out how variables are changing in memory and more deeply investigate what's going on when you really have no idea what happened. Another recommendation I'm making, this is at least half as much convention as anything else, is I think that it's really nice to learn how to make documentation with Sphinx. A ton of projects are using Sphinx. There aren't all that many alternatives that are normally used, and it's definitely a nice tool and good enough. And essentially what it does is when you write your code, you can and probably should normally label your functions and classes with doc strings that explain, basically what they're supposed to do and can explain additional details. What Sphinx can do is it can actually slurp those up as part of a narrative reference documentation. So you can it's not completely fully automated documentation in the sense that it's just a dump of everything that you have in your code, but actually it allows you to write to your readers, and then where you need to conveniently refer to something that was in a doc string or some property of your code, you can just sort of automatically bring that into the documentation. And of course it stays in sync. So if you update the doc string, you rebuild the Sphinx docs, then your generated documentation is still in sync with your doc strings, and it saves a lot of work and is a nice way to do documentation. I know not everybody all the time wants to do documentation, but if you are working with other people, it's super helpful and important, and especially if you are trying to sell other people some sort of open source project, it's extremely nice for them to have documentation. So I have a basic guide on some of that stuff, although it's very light, and the Sphinx documentation itself is also very good. So I really recommend, if you're going to stick with Python, that you learn Sphinx at some point. My last concrete recommendation is that I think that people overrate the difficulty of creating Python packages, and I think that it solves a lot of problems. Really you're just writing this file called setup.py, and the truth is not that many people have really memorized what to write in setup.py. They just have a little template and copy it from one project to another. But my contention is that you can learn how to make a Python package in one afternoon. It's not really that bad. I have a simple guide on it. There are also other guides you can use if you want to, but it's a big advantage from the standpoint that if you want to reproduce an installation of your code, you don't have to manually follow some sequence. If you want other people to install it, you don't have to give them some sequence of instructions to follow. It is pretty much nicely automated, and it also, of course, which is insignificant, allows you to publish your stuff to PyPI yourself. So I'm actually finishing halfway through the session. But essentially my bottom line is this, that if you feel that you're frustrated and you feel that things aren't going well, then it might be time for you to slow down and take a look at what you're doing and carefully invest time into practices or learning something that is going to help you in the long run. And another thing that I'd say is, different tools have different designs and make certain assumptions about how they're going to be used, and when you too badly fight those assumptions, then you have recurring running battles. And this happens a lot with things like Python. So if you decide, for example, that you don't want to do pep8, I understand it's all ultimately kind of arbitrary, but there's so many things in the Python ecosystem which assume that you're using pep8 that you're going to have this recurring battle. And the same goes for me. When I go and I use the Go language, which I don't know very well, it doesn't use anything like pep8, and I like pep8 better now after years of Python, but I just need to suck it up and use Go's native format because I have to work with other people and not be a jerk. So, and not constantly get frustrated. So that's essentially my bottom line. And that's it. Here are links to these slides and links to the website. And I have an address if you have longer questions or anything. Please feel free to contact me if you have any sort of thing. So we have 30 minutes. So if people want to discuss anything or come up here or whatever, I don't care. Any questions?
When you create a virtual environment, it's just running in that, it's running that frame, or is it running in the background when you're wrong?
So essentially what virtualenv does is you have this mini installation of Python in another directory, and it updates the environment variable path so that when you type Python, it actually looks first in the mini installation. And when it runs that Python,
Does it just roll into that shell?
okay, that's actually a good question. It isn't necessarily specific to the shell, but if you use that line that I mentioned about source blah blah blah, that changes the environment of the current shell, and that's the way it's been done for a long time. But you don't necessarily have to do it that way. If you, for example, if you want to run anything at all using that virtualenv, you can actually do that by directly specifying the path to the Python binary that is inside the virtualenv. So if you make virtualenv, and then you'll find that there's inside env, there is a directory called bin, and inside bin there's a Python binary. So if you said env bin Python, that's running the virtualenv's Python, which is going to drag in its own set of libraries. And so of course if you put the name of whatever script you want to do after env bin Python, it's going to run that inside the virtualenv. So you don't necessarily have to use the shell. Also, I wrote a tool, I have a lightning talk later, blah blah blah, which allows you to bypass some of that shell stuff if you don't like it. But there are tools that are nice for that are a little bit less raw for working with virtualenv other than my stuff. Virtualenv wrapper is very well known. It is more shell script, but allows you to just be like, you keep a whole bunch of virtualenvs at a certain point in your certain directory, in your home directory, and then you just refer to them by name. So I say mk virtualenv, this is virtualenv wrapper, not virtualenv, mk virtualenv foo, and then I say work on foo, and then it does that shell stuff for me. And then I'm inside the virtual environment until I type deactivate. That's how virtualenv wrapper works. And so a lot of people, it's one of the standard things, a lot of people use virtualenv wrapper. And this is one of those areas where I differ a little bit from the mainstream, and that I stopped using virtualenv wrapper. But you can use it or not, it's totally valid. Does that help?
Yes.
Okay, there was a question over here.
Yeah, what's your take on integrated development environments?
Right, so boy, I sound really repetitive. I'm really repeating myself. I have 2 lightning talks. At the end of the day, one is about a virtualenv tool, and the other one is about editors. And when I say editors, I'm referring, yeah, well, I could probably and just like leave the space for other people. But when I say editors, I mean also like IDEs. And actually, it's a huge topic, and I have strong opinions about it. But I kind of feel like whatever you use, it should be something that you like, after like careful consideration. But I can't like tell you what you should use. If you told me 10 years ago, use Vim, I'd be like, oh man, I just can't stand that. Like, I just can't deal with it. It's not my thing. Okay, now I use it all the time. So that kind of opinion can change. But there are multiple IDEs that are actually quite competent, and there are also multiple IDEs that are not very competent. But a lot of the really high profile ones are actually quite workable. The PyDev for Eclipse is fine, although it's slow. PyCharm is fine. Wing IDE is pretty good too, and pretty snappy. So there's many options out there if you want like a commercial IDE experience, sort of like Visual Studio. You don't have to do that if you don't want to, though. It has to be something that you like that comes from you. Is there anything else? All right. Since I've left all this time over, I might as well get my lightning talks.